Hello everyone, it's Mr. Spinelli, and today I'm going to go over how to find the greatest common factor, also known as a GCF. First, I'm going to talk about what a factor is, which is another word for factor is divisor. And my favorite definition I found online was from Encyclopedia Britannica, and it is a number or algebraic expression that divides another number or expression evenly. That means there's no remainder whatsoever. So let's talk about finding some factors of the following integers or numbers. Now I'm going to actually write the factor pairs because it's going to be helpful when we start to factor polynomials. So I know that one number that divides every number that I can think of is the number 1 and the number itself. So I always like to start with those and then work my way up. So I notice that 24 is even, so I know that's divisible by 2. 2 goes into 24 12 times. Next number is 3, which goes in 8 times. And then 4, which goes in 6 times. Now notice that as I go down this list, the numbers get closer to each other. So 3 and 8 are closer to each other than 2 and 12, and 4 and 6 are the closest of all of these factor pairs. So my next logical number to try would be 5, but this number doesn't end in a 5 or a 0, so I know I'm done. You technically know you're done when you get to the square root of the number, and the square root of 24 is almost 5, but not quite, so I know that I could stop when I get to 4. That's just a technique you can use when you're trying to find all the factors of a number or determine if it's prime. So 21, I know that 1 and 21 divide it evenly. I know this number is not even, so I'm going to try 3 next, which goes in 7 times. Now the square root of 21 is not quite 5, so 4 is the highest number I should check, but this number isn't even, so I know 4 doesn't go into it, so I'm done. So number 36, I know that 1 and 36 ends in an even number, so I know 2 goes in, and it goes in 18 times. 3 plus 6 is 9, so this number is divisible by 3 because 9 is divisible by 3. 3 goes in 12 times. 4 goes in 9 times, 5 doesn't go in at all, and 6 goes in exactly 6 times. And I'm done because the square root of 36 is 6, so I've got to the highest factor pair. So that should kind of be a review of factors. So let's talk about what the greatest common factor is, or also known as GCF. So simply, it's the largest number or algebraic expression. The key word is largest here. Let me just leave largest highlighted. So it's the largest number or algebraic expression that divides another number or algebraic expression evenly. So when we talk about GCF, we're going to have a list of numbers or a list of algebraic expressions, or some combination of those. So first one we're going to look at is 10, 8, and 3. I want to find the GCF of these three numbers. So what I like to do, and I won't do this all the time, but it'll especially be useful with bigger numbers, is make a factor tree. So 10 is divisible by 2 and 5, and 2 and 5 are prime, so they can't be broken down any further. 8 is divisible by 2 and 4, but 4 is divisible by 2 and 2. And 3 is a prime number, so it's only divisible by 1 and 3. So I would typically write that 10 is equal to 2 times 5, 8 is equal to 2 times 2 times 2, and 3 is equal to, well, 1 times 3, or just 3. There's nothing exciting about it. So now I would look at all these numbers and see if there's any overlap. Well, I know right away that 3 is not in any of the other numbers, so the greatest common factor is simply 1. So in this particular instance, it actually helps to write times 1 on all of these, because that is my GCF. Since 1 is the only number that divides all three of these numbers evenly. So let's take a look at a more complicated example. 126, 162, and 180. So again, I'm going to make my little tree, my factor tree, And since I know this number's even, I'm just going to go with 2 and 63. I remember 63 is 7 times 9, and 9 is 3 times 3. And now I'm left with all prime numbers. 2 can't be divided anymore. 7, 3, and 3 are all into their smallest parts. They are prime numbers. So now I'm going to do the same for 162. So 162, I notice it's even. It's 2 times 81. I know 81 is 9 times 9. Well, 9 is 3 times 3, and this 9 is also 3 times 3. So there's my numbers. This is called prime factorization. And lastly, for 180, I know that it's 2 times 90. 90 is 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. So I'm left with 2, 3, 3, 2, and 5. So let's write out what this looks like. So 126 is equal to 2 times 3 times 3 times 7. You could also write this as 2 times 3 squared times 7. So this is the prime factorization of 126. 162 is equal to 2 times 3 times 3 times 3 times 3. So there's 4 3s. So 2 times 3 to the fourth. And then 180 is equal to 2 times 2 times 3 times 3 times 5. Or 2 squared times 3 squared times 5. Now I'm going to go through and see how many numbers appear in all three of these numbers, 126, 162, and 180. They've all got a 2. There's no other 2's in the top two numbers, but they've all got a 3, and they've all got another 3. So then the GCF is equal to 2 times 3 times 3, which is 18. So again, I'm looking for the overlap in these three numbers' prime factorizations. Another place you can see it is written over here. So they each have a 2. They've got just one 2, so I can only take one of those 2's, not both 2's. And then I take the smallest exponent. So let me actually undo that. I take the smallest exponent of the 3, which is 2. So 2 times 3 squared is another way to think of my GCF. So let's get into the fun part and factor out the GCF from some expressions after we look at one more thing. Actually, I'm going to skip this. So let's find the GCF of this, which now has a polynomial. Or sorry, yeah, there's technically monomials. These are all monomials. We've got a third degree monomial, a sixth degree monomial, and a seventh degree monomial. So I'm going to break down the 75, and I'm going to do this a little bit quicker because I'm trusting that you've practiced and this is all kind of review. So 75 is equal to 3 times 5 times 5, and x cubed just means x times x times x. Well, we saw before that 3 is prime, so this is just 3, and then 6 x's. Okay, and I'm also going to write this as 3 times 5 times 5 times x cubed, 3 times x to the 6th. 20 is equal to 2 times 2 times 5, and then there's 7 x's. 3. Or you could write it as 2 squared times 5 x to the 7th. So we look through and we see what they have in common. Well, 20 doesn't have any 3's in it, and 75 and 3 don't have any 2's. So the GCF of the coefficients of these polynomials is simply 1. And then if I look at the x's, all I've got to do is look at the smallest exponent. So then my GCF is 1x cubed, or just x cubed. So let's start factoring out these GCFs. So here's a whole bunch of examples. I'd invite you to pause it and try it if you already know what you're doing, and you can check your answers. So we look at the first one. I look first at the coefficients. 12 and 5 have nothing in common, no factors in common. But of these expressions, there's one x here, so I can factor out a single x. Now what does it mean to factor? When I'm factoring out an x, what I'm really going to do to all of these terms in the expression is I'm going to divide by x, because that's what I've factored out. Well, if I have two x's divided by a single x, I just have one x left. And since I'm not dividing the 12 by anything, I still have 12. So I've got 12x. When I divide the x by the x in the next term, I get 1. Well, 1 times the negative 5 is negative 5. Now, what I should do is stop and check my answer. So this is my answer. This expression factors to what I have written in pink. I should check it though. X times 12x gives me 12x squared. X times negative 5 gives me negative 5x, which is exactly what I started with. So I can always check my factoring by simply multiplying my answer out. So next one, 16 and 8, well, they both have an 8 in common. And x squared and x, I can pull out the smallest number of x's, which is just 1. So now I'm going to divide this by 8x when I figure out what's left in my parentheses. So 16 divided by 8 is 2, and I still have an x left over. And 8x divided by 8x is 1. The most common thing people forget is to write the plus 1, because they think because they factored 8x out that it's just gone. But there's still a 1 left over. And of course we could check 8x times 2x is 16x squared. 8x times 1 is 8x. So let's go through the next one a little quicker. 32, 16, and 40 all have an 8 in common. And then the smallest number of x's is 1 on this last term. So then 32 divided by 8 is 4. X cubed divided by x, well, remember your properties. X cubed divided by x is really x cubed divided by x to the first. All I have to do is subtract the exponents. So 3 minus 1 leaves me with 2 x's. 16 divided by 8 is 2, and then I still have an x left over because 2 minus 1 is 1. Negative 40 divided by 8 is negative 5. And I've already factored out all the x's, so I'm done. Again, a quick check. 8 times 4 is 32, x times x squared is x cubed. 8 times 2 is 16, x times x is x squared. 8 times negative 5 is negative 40, and there's an x along with. Next one, I notice that all the coefficients are divisible by 4, and there's no x in this last term, so I can't factor out any x's. So all I'm going to do is divide all the coefficients by 4. So I get 7x to the fourth minus 10x cubed plus 2. A quick check. 4 times 7 is in fact 28, 4 times negative 10 is negative 40, and 4 times 2 is 8, and then obviously those x's tagged along for the first two terms. On the next one, all of these numbers are divisible by 3, all the coefficients, and 2 is the smallest exponent, so I can factor out x squared. 27 divided by 3 is 9. 7 minus 2 is 5, so I've got x to the fifth. Negative 12 divided by 3 is negative 4. 3 minus 2 is 1, so I just have a single x left. And then negative 9 divided by 3 is negative 3. And I already factored out the two x's, x squared, so there's no x's left in that last term. And multiplying through, 3 times 9 gives me the 27. 2 and the 5 add to make 7. 3 and the negative 4 multiply to make the negative 12. X squared and the x multiply to make x cubed. And 3x squared times negative 3 is negative 9x squared. Now on this last one, I notice they're all divisible by 3. So I've got 3, and then the smallest exponent is 2, so I can factor out x squared. So then 6 divided by 3 is 2. 5 minus 2 on those exponents gives me 3. Negative 15 divided by 3 is negative 5. 4 minus 2 leaves me with x squared. 18 divided by 3 is 6. X cubed over x squared leaves me just an x. And then finally negative 12 divided by 3 is negative 4. So that's just a quick run through. I'll let you multiply out to verify that one. And let's see a few more complicated ones. So these ones involve coefficients, x's, and then additional variables. So all my rules are still the same. What's the greatest common factor between 36 and 12? Well, 12 goes into both of those numbers. Then, what's the smallest exponent on x's? Well, it's 1 here, so I can only pull out a single x. And then what's the smallest exponent on the y's? Well, it's 3, so I can only pull out 3y's, or y cubed. Smallest exponent on the z's is 2. So I can only pull out 2z's, or z squared. And then what am I left with? 36 divided by 12 is 3. I pulled out one of the x's, so I still have 2 x's left. 3 minus 1, if you want to write the 1, that's okay. 3 minus 1 is 2. So again, I'm just subtracting 3 minus 1, 5 minus 3, and 7 minus 2 to get my new exponents. So 5 minus 3 for the y's gives me 2. 7 minus 2 for the z's gives me 5. On to the next term. I factored that whole thing out. So I should just have a 1. And again, if I were to distribute the 12x y cubed z squared into the parentheses, I would get exactly what I started with. So then on the next one, 72 and 20 are both divisible by 4. And then I'm going to go through and take out the smaller of the exponents. So 12, 5, and 4 for a, b, and c respectively. So I've got a to the 12th, b to the 5th, and c to the 4th. Now I've got to divide both of these terms by what I factored out, my GCF. Remember, this is always your GCF, whatever you factored out. And if you notice that whatever's left in parentheses still has something in common, that means you didn't get the greatest common factor. You just got a greatest common factor, not the greatest one. So you can still factor out more. So it never hurts to just keep factoring until you get what you need. So then 72 divided by 4 is 18. I already pulled out all of the a's and all of the c's, so I'm just left with b cubed because 8 minus 5 is 3. 20 divided by 4 is 5, but I've still got to bring the negative with. 15 minus 12 leaves me with a cubed, and then 7 minus 4 leaves me with c to the 3rd. Now the last one was just for fun. I hope you paused the video before you saw me do these. These two terms have absolutely nothing in common. So you cannot factor out a GCF. I hope you enjoyed the video, and I'll see you next time.